then we have the following. There is a number C in that interval from A to B such that the slope, the first derivative of this function at the point C is exactly the slope from the interval from A to B. Over B minus A. Okay, this is what the theorem says. We can visualize it in the graph like this. For example, this is the coordinate x, y, for example, and this is the graph like this on the interval from A to B, and A here let us call from 2 to 8 in this situation. This is the function f of x. So it says that, okay, here fa b minus fa divided by b over a, which will give us the slope of this one, right? And this is decreasing, so the slope should be negative. And it says that, okay, there is a number between this interval such that the tangent line at this point will parallel to this secant line. Okay? This is what it says. Okay? The f prime at C will be the first derivative, right? Or it will be the slope of the tangent line. And according to this formula, we see that, okay, these two lines are parallel to each other. Okay. And another situation. Somehow, if we are given a graph like this one, in general, it goes from A to B here. Okay, the theorem says that, okay, now before doing anything, let us draw the secant line from this point to this point. Okay, then we see that the slope of this, which is FB minus FA over B minus A, it will be this slope, right? With this guy. And the theorem says that, okay, there exists a point such that the slope of the point C will be exactly the same as the slope of this secant line. Okay, so in this case, how many C's do we have? Yeah, 2. There are 2 points satisfying that. Let us call it C1 and C2. So this is what it says, okay? Or sometimes we write it in terms of the slope of the secant line from the point A to B, where in this case A is this point, B is this point, okay? Here is A, this is B. And this secant line has the slope m of AB be FB minus FA over B minus A. Okay? This is the theorem. Now, everyone take a look at the paper I gave you. Okay, look at that. For people on Zoom, you can download it and open it, please. Okay, here. Again, we play with this function, okay? F of x is x cubed minus 3x. Then the question is, find the number c that satisfies the conclusion of the mean value theorem from interval from 0 to 2. This is the interval from 0 to 2, right? The hint, the mean value theorem is that if f is a function satisfying two conditions. First, it is continuous on the closed interval. In this situation, is it continuous? Yes. Second, it's differentiable on this interval. Because this is a polynomial, therefore, there's a differentiable on this domain. Excuse me. Okay. So, and here is the conclusion of the mean value theorem. This equation, right? Or from this, we could also write as FB minus FA equal to F prime at C, and then multiplied by the difference of the interval from B to A, right? The same thing. Okay, now, how can we solve it? If you see this in the test, you may need to follow these steps. Can you see it clearly for the people on behind it? Is it better for you now? Or you can look at your notes. Okay.
Mr. Tran?
Sure.
Do we have to download this? Because I'm just kind of writing notes in my notebook. Like, are we gonna need this paper later? Or can I just write it down in my notebook?
The best way is to print it, but I don't know how you can modify it yourself.
Okay,
now,
I'll just download it myself then. Thanks.
Yeah, then follow now here, download it, and take a notes during the session, okay? For the people in class, you're given the notes already. So now, in order to apply the mean value theorem, we need to check two conditions, right? First, whether it is continuous, and second, whether it is differentiable on this interval. So, because here you can see it, I explained some things here, you can simply fill in a blank. F is a polynomial of degree 3. Therefore, it is continuous in all R for any numbers, right? And in this domain is an interval in R. Therefore, it is continuous in this interval. And it is differentiable on this. So which number should we put here? Louder? Yes, it is correct. But in this question, the domain is from 0 to 2, right? Right here, okay? So this is our domain, is from 0 to 2, right? The polynomial is continuous and differentiable on this interval. So it should be also It's also be 0 and 2, right? Thank you, Morgan. So the next step, the similar thing, it is continuous differentiable on this interval as well. Excuse me. So the same story. It is differentiable on this interval, right? So the mean value theorem says that if it satisfies these two conditions, then there exists a number C within this interval from A to B. In this case, it would be 0 and 2, right? So what is the things we need to fill in here? Very good. Oh, sorry. F of 2 minus f of 0 divided by? Yes. We just apply the theorem, right? Nothing new. Now, in order to find C, what do we need to know? Yes, the derivative of this function at the point C. What else? Yes, this guy and this guy, right? We need to evaluate the value of this. Okay, so the function is f of x is x cubed minus 3x. So what is f of 0? Thank you. And f at 2? Say it again, please. Very good. Okay, it would be 2, right? How about f prime of x?
3x squared.
Very good. It is 3x squared minus 3, right? So take the derivative of this will be the derivative of these two, which is x cubed derivative minus 3x prime, because this is a constant. Very good. So we have this. So in this case, we need to evaluate the first derivative at a point C. So what is f prime of C in this case? Louder? No, it's not 1. Not yet. So this is true for any x in the domain, right? F prime of any x. So at the point here, x is equal to c. See? So it means that we need to substitute c to the position of x here, right? It means f prime at c will be 3 times c squared minus 3, right? So we have that. What can we do now? Let us simply write it in another way. We factor the common things out. It's better, right? So what is the like term here? Very good. So if we factor 3 out, what do we have? Very good, thank you. So we have this, right? And we can also write it as, yes, Thank you. So now we have f prime at C. We have f at 2, we have f at 0. So we can substitute here, right? Therefore, it is 2 minus 0 divided by 2 minus 0. It means that f prime at C should equal to 1. And we found f prime. Oh, actually, we don't have to factor it out. It's okay. F prime at C on the left-hand side is this guy, right? This case, we don't have to factor. It means that we have 3c squared minus 3 should be equal to 1, right? Now our job is to find the number c. Okay? What should we do now? Louder, please. Yeah. Yes, add 3 to both sides, and therefore we have 3c squared will be 4, right? Thank you, Marissa. So what should we do now to find c? Yes, it means that c squared should be 4 divided by 3. And then there are two cases, right? C would be? Yeah. So plus square root of 4 over 3, or C would be minus square root of 4 over 3, right? We have that. But the domain is from 0 to 2, okay? We're looking for a C from this interval. Therefore, we can
Mr. Tran,
yes.
why can C be equal to square root of 4 over 3 or negative square root of 4 over 3? Why is it why do we include the negative 2?
Okay. So there are two numbers that when we square it, give us the same result, 4 over 3, right? The first one is this guy. The second one is this guy, right? Do you agree?
Yeah.
That is why, yeah.
Okay, thank you.
You're welcome. Who was that?
Logan?
Logan, thank you, Logan. So we found two numbers, and we are allowed to pick the number from 0 to 2, because that is what we're looking for, right? So therefore, we can only pick one value, which is square root of 4 over 3, or we can write it 2 over square root of 3. They're the same thing, okay? Now, we found it already, right? Go back to the graph of this. Okay, look at this. The secant line from the point 0, 0 to the point 2, 2 will be this line. Okay? And the point axis square root of 4 over 3 will be 1 point something, right? It is somewhere here. Okay? It says that the slope of this point will be the same slope of this parallel to this, right? Yeah, it would be like this. Okay? And this is the slope, which is a prime of C. Okay? This is the mean value theorem, tell us, and we can find that. If now we extend our problems, okay, let us consider the same problems, f of x, but now the domain, we consider it from -2 to 2. Okay? In that situation, how many values of c can we find? Yes, 2. The first one is square root of 4/3 right here, or 2 over square root of 3. And the second one will be? Yes, -2 over square root of 3, right? And the slope of that would be a similar story. It would be like this, okay? So you don't have to do many problems. Just do one problems, easy problems that can help you understand everything. And this is an example. Whenever you study the mean value theorem, remember this graph, okay? So now, suppose that, so do you have any question for me here? Is it clear? Okay, very good. Keep these notes so that in the future when we take the test, review it. Okay, now the second question, the similar question, okay? Find the number of C, the number C that satisfying the conclusion of the mean value theorem from the interval, in the interval from 0 to 4. Okay, what should we do? Yes, the same story, right? We need to check if it is continuous. And actually, the square root here, it is continuous for positive x, right? The condition, okay? Let us do it here. So the domain, in general, we have the condition that, what is the condition of the square root function? The terms under the radical sign should be positive, right? This is square root. We are not allowed to pick a negative number and put it here. So the condition is that x is positive. And here, our domain is from 0 to 4. So we're good. Okay? And we know that this rational function is continuous on the domains. Okay? And therefore it is continuous. That is the first condition. Second, it is differentiable on the interval from 0 to 4, right? That is the properties of a rational function, okay? Satisfying these two conditions, therefore, we have the conclusion from the mean value theorem. We say that, okay, there exists a number C in the interval from A to B, in this case is from 0 to 4, right? Such that f prime of C will be, what is it here? Yes, 4 minus f of 0 divided by, yes, this is what we have from the mean value theorem, right? Okay, the same story. We need to compute the derivative of this function at the point C, right? a prime of x or a prime of this one. What is it? Say it again. Yes, very good. Thank you. Who was that? What is your name? Oh, Carson. Yeah, you wear a mask and I don't know where the sounds come from. Okay, thank you. So we have this, right? Therefore, what is the derivative of this function at the point C? Yes, we have this. Very good. So we found this guy, right? Okay, let us continue. Ah, I see. We have another way. We add one more page here. Very good. Interesting. Excuse me. Okay, let me copy it here. And we continue here, okay? Yes. Okay. We got this one, okay? And what else should we know? Yes, square root of 0 or simply 0. And f of, yes, which is 2, right? Therefore, we have the equation that 1 over 2 square root of c should be 2 minus 0 divided by the difference of the interval, which is 2 over 4, right? Or 1/2. Okay, we got that, right? So, what does it mean? How can we find C? Louder?
You said 1/2 equal to square root of x, square root of c.
We need to solve this equation, right?
Ooh.
Yeah, I cannot hear you clearly, but we flip it first, right? If we flip both sides of the equation.
Well, he drives me insane.
Or if you multiply, yeah, there are many ways you cross both sides. And it simply gives us 2 square root of c will be 2, right? Practice doing this, you see it faster. And then it implies that square root of c will be 1. Therefore, what is c? Yes, square root of 1. Oh, if we square both sides, then okay, the c is equal to 1, right? And 1 does belong to that interval, so we are good. So that is the number we need to find. Okay. So do you have any question for me? Is it clear?
You got 2 square root of c equals 2 from 1 over 2c equals 1 over 2. You just got rid of the 1 on top, right?
Yes, correct.
Got it. Thank you.
You're welcome. Or the faster way to see it. Look at this. This is 1 over 2 square root of c. And imagine the right-hand side is 1 over 2 times a number 1, right? It makes sense to immediately go from here to here and conclude that square root of c should be 1. Okay? There are many ways to think about it. Okay, that's it for this types of problems. So very good. Now, let us play with this example. One more. Okay, verify that the function f of x which is x cubed minus x squared minus 6x plus 2 satisfy the hypothesis of Rolle's theorem. On the interval from 0 to 3 and find all numbers C such that satisfy the conclusion of the Rolle's theorem. Okay? So we are asked about the Rolle's theorem, right? Therefore, let us review it. Okay? So the Rolle's theorem hypothesis is that first, f should be continuous on the closed interval from A to B. In this case, we are given that, okay, from 0 to 3, right? Second, f is differentiable on the interval from A to B. Third, fa should be equal to fb. Okay? If a function satisfying these hypotheses, then we conclude that, okay, there exists a number c from this interval from A to B such that the derivative of c will be 0. Okay? Now, we need to check all these, okay? First, can you tell me if it's satisfying the first condition? Yes, and why? Yeah, same story. Polynomial is continuous, differentiable in R. And this is small interval in R, so therefore it's satisfying. from 0 to 3. Very good. And the same story, it is differentiable from 0 to 3. Okay. And we need to check the third condition. In order to check it, we need to find the value of that function at 0 and the value of that function at 3. So, what is f of 0? Be careful. Just 2, right? Yeah, just 2. If you ask this in the exams, we guess that, okay, it should definitely be correct here. It should be 2, right? Or the correct way is to double check it. 2 cubed, let us do it. Cube minus 2 square minus 6 times 2 plus 2, right? And you do this calculation, you know that it is 2, then it's satisfying the third hypothesis, okay? So we conclude that F satisfies the Rolle's theorem hypothesis. Okay, it's satisfying, therefore there exists a number C from 0 to 3 such that f prime at C should be 0. Okay? So we need to find C. How can we do that? Again, please. We need to find f prime of C, right? And f is given here. Yeah, find the derivative. We have it here. So therefore, the derivative of this guy will be the derivative of these. And what do we have? And very good. Yes, we have this, right? So then we need to solve f prime of C, which will be 3c squared minus 2c minus 6 equal to 0, right? Okay? So, can we do it quickly? Using some trick we studied before? Cannot, right? So, then we just use the formula. C1 and C2 will be minus B, right, the formula, plus square root of discriminant divided by 2 times A, right? Let me just write it, plug in the correct number so it won't confuse you. So negative of, do you remember the formula? Yes. And the discriminant, what is the negative 2 squared and yes, very good. Be careful with the negative sign. Very good, Carson. Divided by perfect. So let us compute it together. Negative of negative 2 gives us 4 plus square root of this is 4. 4 and 4 times 6 here times 3, so we can factor 4 out. Right, inside that it is 1 plus 6 times 3 will be 18. And the denominator is 2 times 3, right? Let us leave it this way. And the same story for the second numbers. It will be C2 will be negative of negative 2, subtract the discriminant here, which will be the same here, 4 times 1 plus 18, divided by 2 times 3, it will be 4, subtract this guy, 4 times 18 plus 1, which is 19, okay? Divided by 2 times 3. So we have two solutions here. Let us simplify it further, okay? C1, can we simplify it and help me, please? Very good. So it is very good, but let me just write it slowly. 4 is 2 times 2, right? I'm sorry? Oh, I don't know why. I'm sorry. How can I do that? Good job. Okay, thank you. Okay, now this guy is square root of 4 times 19. So 4, it is square root of 4 times square root of 19. Square root of 4 gives us 2, right? 2 times square root of 19 divided by 2 times 3. So 2 is a common factor in the numerator. So we can factor it out. What is it inside? Very good. And C2, the similar story, but there's only different. One thing different, that is the negative sign. Which will be 2, 1 minus square root 19, 2 times 3, right? And here, they are a product. So 2 will cancel with 2 here, right? And finally, we found two values of C. The first C is 1 plus square root of 19 and then divided by 3. C2 is 1 minus square root of 19 divided by 3. Okay. Then we found two numbers, is it right? No, we cannot accept both, right? Very good. And here, 16, square root of 16 is 4. Therefore, square root of 19 is smaller than negative 4. So smaller than negative 4 plus 1 will be a negative number. Therefore, this number is smaller than 0. So we cannot take this one. right? This one, 1 plus square root of 19, it is about 5 point something or 6, and then divided by 3, so we're good. It should be between 0 and 4, okay? Let me see. 0 and 3. Smaller than 3. Use a calculator, okay? Then we conclude that, okay, we found only one number C which belong to that interval, okay? Thank you and see you tomorrow. Bye everyone.